Okay, so we are on the final question in Introduction to Statistical Learning, Chapter 6. Um, and I guess here it is right here. This question is just slightly confusing um, because I went through and answered A and then realized that in doing A, you basically answer B and C. So what are we going to do? We're going to look at the Boston data set, and we're going to try to model crime rate per capita, based on the other variables in that data set. And so we're going to use several, kind of variable selection methods, such as subset selection, lasso, ridge regression, PCR. So I just did each of these except for ridge regression because that's basically, the mechanics of doing it are basically like lasso. So just to kind of keep it a little bit more simple, I omitted doing ridge regression. Um, and then we propose a model or set of models that seem to perform well on this data set. Okay, well, the way that we do that is already done in part one, where we're trying out these different methods, and each one of these methods is going to select, a set of variables. So there you go. And then we're supposed to evaluate the performance based on cross-validation or some other alternative, or using a test set. And I just use a test set as I went through all of this. So that's done in part one. And then, does your chosen model involve all features from the data set? Yes or no? Why or why not? And so each one of these models, it's going to select some set of variables, and so yeah, so not in all cases will all of them be used. Okay, to do this, I really just copied and pasted some of the work previously. Whenever we did like subset selection or lasso, I just copy pasted and modified it for this particular data set, but we'll go through it nonetheless. So you need to load the ISLR2 package and load the Boston data set here. And we can kind of see what that data set looks like. So CRIM here is crime rate per capita, and you would know that if you were to open up the help file. So CRIM is per capita crime rate. So, right there. All right. So let me bring back the structure of it. Okay. So like I said, my validation method here is to just break it into a test set and a training set, and so that's all this is doing, right? So I have this many observations, and I'm going to use 80% of them to train. Okay, the rest of them will be the test set. So how many observations is 80%? Well, it's this many. I guess really I should put like ceiling or floor here to make sure that I'm getting an integer. Guess I'll do that. And then so from that, so I'm going to sample 1 through n, which is the possible values or the possible observations. And how many am I going to sample? I'm going to train n of them, right? So 80% of the data, roughly 80%. And then my training data is just the data that has a training index that has been selected from that line above, right? And then the test data, and I've also broken it down into X train and Y train because some of the methods that we use, this is easier to put into the command rather than the whole data set here. And then the test set is, well, it is just simply those not selected in the training index. So there we go. So we'll run that. Okay. So the first one I did here was best subset. Again, this is done previously in this set of questions, so I'm not going to do a lot of explanation here, but you need to make sure that you install and load the LEAPS data set. And then we just use this reg subsets command. And so I'm regressing crime on everything else, and I will check up to PN possible predictor variables. What is PN? Well, it's the number of columns in the remainder of the data set. Okay, and so then when I go through this, I'm going to select the one that does best. Here we go. I go here. So I have my training residual sum of squares, right? And it happens to be the one that I guess has all of the variables in there, 12 of them. But then I want to verify this. I want to verify this then against the test set of data. And on this particular partition of the data into test and training sets, it is 2 variables apparently that is doing the best here. And I think we can even find which 2 they are. It apparently is rad and lstat. I'm not sure what these mean, but it's not really important here. If you want to know how we came to finding the test RSS, it's here in this for loop here. Okay, so for each one of the models that is tested up here, we use that to make predictions on the test set, and then look at the error between what the model predicted on the test set and what the actual value was. Okay, and so that for loop just runs through every single model that was found in the test set training exercise. So okay, so next I used lasso. Okay, so this is the code for lasso. So I have my lasso model, and I have my x variables and my y variables for the training data. I set alpha equal to 1, okay, and that means that we're going to do lasso. I believe if you set it to 0, it is ridge regression. Okay, and remember that with lasso as well as ridge regression, we have a penalty term, and the size of that penalty term is modulated by lambda here. And so what lambda are we going to use? Well, we're going to use a whole bunch of them. Okay, so we have so we just have a bunch of possible grid values here, and so we're going to test all of them. Okay, and then we're going to go through and we're going to look for the best lambda, the one that minimizes the error, and then we're going to use the best one to make predictions. Okay, and then we model the error with that set of we model the error, or we calculate the error of those predictions by looking at the predictions on the test set minus what the actual value was in the test set, and then we have the error. So let's look at this. Okay, so the model that is apparently performing the best here is right there. So well, it's this model where tax is omitted, and there's variables for all of the rest, or coefficients for all of the rest. Okay. Now we used PCR principle. Can't remember what PCR stands for now. But we go through the same exercise as we did in the question above. We're regressing crime on everything. This outputs a particular model for us. Okay. The model which is doing the best has 12 variables, and then with that we can go through and we can check it against our test data, where we get a error of such and such. Okay. Like I said, I kind of ran through that just because we've seen all of these before, and so if you have more uncertainty about these, I would actually look at the previous videos. So I guess after this, we are moving on to chapter 7, where we are quote unquote moving beyond linearity, and so there will be just extensions of some of the regression methods that have been learned here.